Okay, let's see. Page 483, number 17. 95% confidence interval for the mean body mass index of all American young women is somewhere between, well, 26.8 plus or minus zero point 0.6. We're confident that 95% of all young women have a body mass index between these two numbers. Well, that's incorrect. It's not for individual women, it's for the average. So if you took all of the American women, we're just estimating the average body mass index is somewhere in there. Okay, letter B. Okay, letter B says, we are 95% confident that future samples of young women will have a mean body mass index between those two numbers. That's getting closer, but not quite correct. I'm not sure what they mean by future samples. Okay, let's look at letter C. So letter C is correct. Any value between these two numbers is believable as the true mean, because remember, that's what we're trying to do with our confidence interval. We're just trying to guess the true mean, and we think that it's somewhere between those two numbers, 26.2 to 27.4. So letter C is pretty good. Let's look at letter D. Letter D is not correct. In 95% of all samples, the population mean will be between those two numbers. No. What we say is, so this is like the confidence level, saying in 95% of all possible samples, we think that we would capture the true mean. Not sure if it's between those two numbers, we just think that it would capture the true mean in 95% of the time. In letter E is also not right. The mean body mass index of young women cannot be 28. Well, this is just one sample, okay, that we took. Okay, there's a possibility that we missed it, and it is 28. Remember, 95%, so this could have been the 5% that was on the outside. So anyway, that is also incorrect. Let's go to the next one. Okay, let's look at conditions. So we've got random, normal, and independent. Well, random is important because we want a true cross-section of our population, sum of everybody, and that gives us better data. Normal is, remember, we have that normal curve. Let's see if I can draw it. So we have this normal curve. That's what we're trying to get, right? Something like that. And now that gives us our ability to make that confidence interval. And then independent helps us ensure that because we're not going to mess with our proportions because of the size of the population, it's going to ensure that our standard deviation is as close as and accurate as possible. Okay, let's look at number 20. Well, number 20 talks about plagiarizing. So they talk about how you can get almost anything off the internet and whether you should give someone an F if you find out that they plagiarized. Now, they take this online poll and 14,000 something clicked yes that they should get an F. Now, which condition is violated? Well, it's random because it's an online poll, meaning it was a voluntary response. People had to go to the website somehow, and then once they went to the website, they had to volunteer to click either yes or no. So, random is violated here, and that means that our confidence interval is not worthwhile. Let's look at number 21. Okay, number 21 talks about a researcher takes a sample size of 500 families to estimate the mean monthly family income from a large population, 99% confidence interval versus a 90% confidence interval. Okay, so let's take a look. How about this? If we look at it this way, this would be like a 90% confidence interval. 90% of the data is there versus 99%, which would be almost out to the ends. Okay, so this would be wider. And we would be fairly certain, 99% certain that our true mean is in between here. So we'd have less of a chance of making a mistake in case our true proportion was outside. Like 90, it might not capture it. So it is choice B, 99% confident is going to be wider with less of a risk of being incorrect. Let's go to the next one. Okay, number 22. In a poll, some people refuse to answer the question. Okay, that does not help us. We get no data from that. Number 2, people without telephones could not be in the sample at all. We get no information from that. And number 3, some people never answered the phone in several calls. Again, we get no data from those people. They're not involved in this poll at all. So the answer is going to be E, none of these. Which sources are included in our 2% margin of error? None. Okay, let's do the next one. Okay, in questions like this, I try to match those sentences that we wrote down in our notes with the answer. We have a simple random sample of 25 employees, 95% confidence interval, somewhere between 122 and 138. Letter A is talking about individual employees, but we want the average for the company is somewhere between there. Number B, letter B, 95% of the population of employees have a systolic blood pressure between 122 and 138. No, we would say that we're 95% confident that the average is somewhere between there. Okay. If the procedure were repeated many times, 95% of the resulting confidence intervals would contain the true mean, the population mean. That sounds like what we did is confidence level. The probability that the population mean is 95. No, that's incorrect. If the procedure were repeated many times, 95% of the sample means would be between these two numbers. No. If the procedure were repeated many times, we would capture the true average, which may or may not be between those two numbers. So the answer is letter C. Okay, let's just say you have polled a bunch of people, you get a normal population, and your proportion is 64%. That's what they're saying. And you're 95% confident that the true proportion is inside that range. So that gives us 95% of the data, which happens to be plus or minus 0.03, 3%. Minus 0.03. Okay. Now, what if you changed it and said, well, let's just be 80% confident, meaning we have a bigger chance of making a mistake, but our interval will be much smaller, like this, because this would give us only 80% of our data, and we think it's in there, okay? So it's a smaller margin of error, but a bigger chance of making a mistake. Let's see. That would be letter B, less than 3%, but we have less confidence that we are correct. So that's the answer to that one.